Good day everyone. Today I will be explaining to you our sorting exercise 2 and I will explain it to you. I will demonstrate it to you on how the merge sorting or the sorting exercises works. First is we are going to import the necessary stuff, the array and the scanner so it let us type things into the program. We are going to start the program. This line right here, the line number 4, what it does is this is just the name of the program. It has Java. We are doing some sorting here. Next, we will begin the merge sort. This static void merge, we are about to start using merge sort. It takes an array, this one, and some boundaries, the left and the right. We are going to check if there is anything to sort. The code right here, if left is greater than right, if there is something to sort, meaning more than one number, we find the mid, and slice it. We are going to sort the left and the right halves. The left and the right halves. What it does is we call merge sort, the one right here and the other one below. On both halves, we keep cutting the array in half until we get to one number. We are going to merge sorted halves back together. The line right here, the line number 16, after sorting each half, we merge them back together into one sorted array. We can see the code right here. There is left, mid, and right. Now the function of the merge sort, now we are going to combine them. We are going to combine the halves. The static void merge, this is where the sorted halves come back together. We are about to combine them. Now we are going to create two buckets for the left and the right. This code right here, we can see there is an L. There is an L. Create two buckets, L for the left half and right, R for the right half. We are going to dump numbers into this. Now we are going to fill the buckets. This right here, we fill the left bucket L, this left bucket L, and the right bucket R with the respective halves of the array. This code right here will do that work. Now we are going to merge the buckets. The code right here, this one, until below. From line 30 to 54, we look at both buckets. Whichever has a small number, we move it back to the array. We keep doing this until one bucket is empty. The possible output is if the array was 3 and 1, we get 1, 3 here. This code right here, and I is equal to 0 and j is equal to 0. What it does is we look at both buckets. Whichever has the smaller number, we move it back to the array. We keep doing this until the one bucket is empty. The possible output is if the array was 3, 1, we would get 1 and 3 or 1, 3. So we are going to add the leftover numbers in this code right here. While I is greater than n1 and while j is greater than n2. If one bucket still has leftover numbers, we dump them back into the array. Now the array is fully sorted. After merging an array like 5, 1, 3, and 2, it might end up as 1, 2, 3, and 5. I am going to show you the results later. Now we are going to move to the quick sort or the fast sorting. We are we are starting the quick sort here. It picks a pivot or a number and sorts number around it. Now we are going to start sorting around the pivot. If low is greater than high, int pi is equal to partition array low high. If we still have numbers to sort, we pick a pivot and split the numbers around it. Smaller numbers go to the left and bigger numbers go to the right. Now we are going to sort both sides of the pivot. This line right here, the 61 and the 62. Oh no, where is it? This, the 61 and the 62. We do the same thing again for the left and right sides around the pivot. We keep doing this until the sorting is over, or it is done sorting, or everything has been sorted. If after a pass, an array like 4, 2, 7, and 1 and might become 1, 2, 7, and 4. Now let's move on to the partition or to find the pivot. Static int here. This code right here. Static int partition until line 68. The pivot plus the number in array. This array high. We start with I is equal to -1, which means nothing has sorted yet. Now we are going to move numbers around the pivot. For each j is equal to low, j is greater than high, and j plus plus, or the j increment. We are going through each number. If a number is smaller than the pivot, we swap it to the left, So for example, we have an array like 3, 6, and 1. It could become 1, 6, and 3 since our pivot is 1 and 1 is going to the left. Now we are going to put pivot in its right place. Int temp is equal to array index. Or this line right here, we are going to line 80 to 84. What it does is we move the pivot to its correct spot in the middle of the array. Now smaller numbers are on the left and the bigger ones are on the right. After moving the pivot, something like 3, 1, 6 could become 1, 3, and 6. Now it is arranged from ascending order. Now we are moving to the heap sort. We start heap sort, or the another way to sort numbers, by turning the array into a heap, or a what we call the tree structure. Now we are going to build the heap. We start from the middle. We start from the middle and work our way back to the top, building a max heap where bigger numbers rise to the top. We are going to heapify the numbers. Now we are going to fix the heap. We are going to fix the heap here, right here, in the line 104 until line 107. We check the current node or our index and compare it with its children the left, and the right to find the biggest number. We are going to find the biggest number so we can start the heaping or the heap sort. Now we are going to swap to fix our heap. This code right here, or this lines right here, it will if the left or the right child is bigger than the current node, we swap them and call, this is what we call the heapify, again to fix the heap. So after a heap pass, an array like 4, 10, and 3 might become 10, 4, and 3 since our bigger number is number 10. Now we are going to measure our sorting time. This this line right here. We are about to measure how fast is each sorting method is. Now we are going to print the result of our now we are going to print the result of our sorted array, this one. This line right here, this, can you see it? So after sorting, we print the sorted array. So if you sorted like 5, 1, 3, and 2, the printed one would become 1, 2, 3, and 5. So it will be in ascending order. Alright, let's continue. And so we are going to end the time measurement. We are going to end the time measurement. This long end time system that nano time. So we stop the timer and calculate how long it took for the sorting and algorithm to finish. So the time here would be millisecond. We can see here the duration. We can, if we print the results in line 139, it will show the duration of how long it took for us to sort the algorithm. And we are going to print the time taken. Yes, that's it. So now let's move on to our main method. Our main method. This is the starting point of the whole program. So everything begins here. Now we are going to set up our scanner. So we create a scanner object so we can take input from the user. So we are going to ask for numbers to sort. This line right here, we are going to ask we are going to ask for a number from the user to type a list like 12, 45, or whatever numbers you like. Now we are going to process our input here, the line right here. What it does is we take the user's input, which is just a big string, and split it into individual numbers stored in our variable inputs. This. Then we create an empty array to hold the numbers. Now we are going to convert the string into numbers. We loop through each number to through each number the user type. We convert it from a string like 12 into an actual number 12 and store it in the array. We are going to store it in the array. Now we are going to ask for some sorting algorithm choice. This line right here, 154 to 155. So we are going to ask the user to choose a sorting method by typing 1, 2, 3, or 4. Our case number 1 is if we type 1, we will choose the merge sort. If we type number 2, we will choose the quick sort. And number 3, in case number 3, measure sorting time, heap sort, array clone. If we if we type 3 into our system, we will choose the heap sort. In For the case number 4, we can see right here that if we type number 4, it will run all three and compare their speed.